when the orthogonality of the system is not warranted, its performance may be degraded due to inter-symbol interference or inter-carrier interference. These ISI and ICI effects causes STO and CFO, which is symbol timing offset and carrier frequency offset. Let the effect be denoted as epsilon for CFO and as delta for STO. These two tables show the effect of STO and CFO on the received signal. In the time domain, for a received signal of y of n, upon STO of delta affecting the signal, the received signal would be x of n plus delta, and the effect of CFO would cause e power j 2 pi n epsilon divided by n as a product to be added to x of n. And in the frequency domain, the STO of delta results in e power j 2 pi k delta by n times x of k for the STO effect, and CFO epsilon affects the signal as x of k minus epsilon. In order to study the effect of symbol timing offset, the starting point of the OFDM system must be accurately determined at the receiver. This allows us to cancel the effects effectively caused due to STO. From the diagram shown, we can see that there are 4 cases from where an OFDM symbol can start. The first case is the ideal case where there is no interference or phase shift, because the starting point of the OFDM symbol is where it should have started. Therefore, the subcarriers are orthogonal and no inter-symbol interference is observed. In the second case, the starting point of the OFDM symbol is ahead of the start point. This lag is because of impulse response. This slight shift results in a phase shift, but the orthogonality of the subcarriers is maintained. In the third case, the starting point is much before the OFDM symbol start, and it is before tau max. This destroys the orthogonal nature of the subchannels and causes both inter-symbol interference and inter-carrier interference effects. Case 4 is where the OFDM symbol starts after where it should have started. This results in additional phase shift compared to case 3, and in this case, the distortion of the received signal is more severe, and the STO effect is more complex to be estimated and corrected. Carrier frequency offset also affects the OFDM system, and CFO arises due to Doppler frequency effect or due to the unstable generators at the transmitter and receiver ends. Also, phase offsets can be observed due to CFO. CFO causes inter-carrier interference among the subcarriers. The diagram represents different frequency bins which are transmitted, and in case of frequency offset, the diagram on the right shows how the frequency bins are affected. We can see that the previous frequency intervals affects the subsequent frequency intervals to cause a carrier frequency offset and interference among the various subcarriers. In order to compensate for the effects of STO, estimation of STO is necessary to synchronize the subcarriers. This estimation technique can either be in the time domain or the frequency domain. In the time-based estimation technique, one of the methods is the cyclic prefix method, which is based on sliding windows. This method works based on sliding one window along the other and to find the maximum similarity between the samples. At the point where the similarity is maximum, the difference is minimum. This technique is used to estimate the value of CFO. Another technique is the training symbol method, where identical symbols are considered or one symbol is repeated, and then the sliding window technique is applied to find the minimum difference or the maximum similarity. In the frequency-based estimation technique, phase rotation occurs due to STO, and therefore the signals can be synchronized in the frequency domain by taking the impulse response of the channel. Similarly, CFO estimation can also be done in both the time-based domain and the frequency domain. Cyclic prefix method is the time domain based estimation technique, and the frequency domain estimation was developed by Moose and Klassen. In the cyclic prefix method, the fractional frequency offset is preferred, and the CFO is estimated as the product of cyclic prefix value and the real part of the OFDM symbol. In the Moose method, the training symbol method is used to improve the mean square error. In this case, the approximate value of CFO is obtained in the acquisition phase, and this approximate value is corrected in the tracking phase method. And in Klassen method, the similar technique is applied, but there are pilot tones or certain bits included in the frequency domain, in the transmitter of the frequency domain, and then at the receiver it is used for tracking the OFDM symbol. Now let us look at the MATLAB demonstration for the estimation of STO and CFO. Here we have the program for STO estimation by the methods of correlation and difference. Now let us run the program and see what the output is. So this plot shows the STO estimated by the correlation method as well as the difference method. For the four figures, the plot in blue shows the STO estimated by the maximum correlation method, and the plot in red shows the estimated STO by the minimum difference method for various values of delta and epsilon. So, and similarly, the blue dot represents the STO estimated by maximum correlation method, and the red dot shows the STO estimated by minimum difference method. The first plot is for a delta value of -3 and an epsilon value of 0. The second plot is for the STO value -3 with a carrier offset of 0.5. The third graph shows the value for STO or delta equal to 2 and for CFO equal to 0. And the fourth shows for STO equal to 2 and CFO epsilon equal to 0.5. And this plot similarly shows for the same values of delta and epsilon the STO estimated using the impulse response of the channel. Now let us look at the CFO estimation techniques. So before we look into that, let us look at the functions used in the STO estimation. AddCP is the function which adds cyclic prefix. AddCFO adds the carrier offset of value epsilon, or which is denoted as CFO. AddSTO adds this function adds an timing offset, and STO by correlation and STO by difference are the two methods which are the maximum correlation method and the maximum difference method. Now let us look at the CFO estimation plots obtained. So this is the plot obtained for CFO estimation based on the three techniques, which is the cyclic prefix method in time domain and the Moose and Klassen methods in the frequency domain. From the plot, we can see that the blue line shows the cyclic prefix method, which results in the maximum mean square error. And from this, we note that the minimum mean square error is in the Klassen method, and so we can conclude that this method is the best among the three. We also note from this graph that as the signal value progresses, the value of mean square error reduces. That is, with a higher SNR value, the probability of error is lesser. Now, let us look at the synchronization steps that occur in cellular systems. Most cellular system mainly consists of two parts, which is the left part, which is the mobile station, and the right part, which is the base station. And the two main types of communication that occurs between these two cell phone and base stations are one would be searching for the cell, and the other operation would be syncing of the two systems. So these two processes are shown in these following steps. In the first one, the downlinks in the first step, the downlink synchronization involves the base station sending out a signal regularly to keep link with the cellular system. Using the signal transmitted, the cellular system gets the values of frame time, symbol time data, and frequency of the carrier. It then sends out a random access symbol using the time data, and uplink estimation occurs at the base station end. Upon receiving the preamble, the values estimated are STO, CFO, and power. The base station modem then sends out a reply to the mobile station with the timing and the CFO value, and in this step at the control channel. And then in the mobile station end, uplink compensation occurs, and the uplink timing CFO value is compensated, and then this compensated uplink signal is sent back to the base station. This is the synchronization procedure that occurs in cellular systems. In conclusion, we can note that the OFDM is a popular methodology in today's high-speed, high data rate requiring communication systems, and it allows us for the future wireless technology to progress, and allows us to view and use it in applications such as video calling, mobile TV, video streaming, and other applications that require higher data rates. This project is mainly focused on studying the basic OFDM system and also observing and analyzing the various effects caused due to symbol timing offset and carrier frequency offset. Also, synchronization techniques of STO and CFO estimation were studied and analyzed using the various MATLAB simulations. And finally, A brief description of the synchronization steps that occur in a cellular system was also seen. Thank you.